So when you look at a graph like this is what is called a scatter plot. It's just points scattered around. Do you see how they're not connected? It's like a little constellation, okay? If we wanted to write an equation for a line, if we did connect them, what would be the slope? Like if we did connect these lines, what would be these points and made a line, what would be the slope? -2. Good. We're going down 2, right 1. So -2 over 1, if you want to put that, would be our slope. What would be b, like our y-intercept in the y equals mx plus b world of thing? Good. That would be 3. And I'm sorry, I don't have a better explanation than it's this point right here. Do you see that, guys? 3. So if you wrote an equation for like, if you did connect these, it would be y equals -2x plus 3. Now, the reason that works is because do you see how the points are all nice and perfect and in an exact line? Well, what if they're not perfect? What if they're kind of scattered about? Then instead of the line being perfect, you're going to use what's called a line. Sorry, I can't write and talk at the same time here. Use a line of best fit. And what that means is it's not perfect, but it's the best we can do. Does this make sense? Like if the points aren't like exactly in a line, they're kind of scattered about. We use what's called a line of best fit. It's like we did our best and the calculator does it for us. I'm going to write all the steps for the calculator here. Then I'll pause the video and I'll write them on the board as well so you can still see them. But basically, this is a lesson where you just type it in the calculator and the calculator gives you the answer. Okay, so pay attention to the steps. So first of all, we need Desmos graphing. It has to be the graphing calculator for this one. Up till now, it hasn't really mattered which calculator you use, but this is going to have to be Desmos graphing. All right, so you're going to click the plus sign and choose table. And I'm going to take you through all these steps. It's just I have to write them all down first so that I can flip the paper over and we can go to the problem, right? So you're going to click the plus sign and choose table and then enter the data. That's going to be given to you. And that's just mindless button pushing. That's like brain optional. Do you know what I'm saying? Like you just have to make sure you don't mistype a number. Like don't do a typo or your entire answer will be wrong. Okay. So you're going to enter the data and then click the magnifying glass. And what that will do is it will choose a good window for you. It will make the data show up perfectly in your window. Like the calculator literally does it for you. And then to make it give you the line of best fit, to make it give you that prediction, it's y equals mx plus b with like a couple small alterations. Watch me write this, and then I'll give you a chance to copy it down. Don't write it yet. Here's our y equals mx plus b. There's 2 things we're going to change. Instead of an equal sign, you're going to use what's called a tilde, that little squiggly thing. The reason why is because it's not perfect, remember. It's like an estimation. So it's like not equal. It's like almost equal. It's like a wiggly equal sign. And then it also makes you put ones after the x and the y. So that's what I want you to write down. It's y equals mx plus b. It's just instead of an equals, you have the like wiggly equals. And you have to put a 1 after the y and the x. So those are your steps. To make predictions, you're either going to be given an x, predict y, or given a y, predict x. And again, the calculator will do this for you as well. You're either going to put in x equals, whatever number they give you, or y equals whatever number they give you. Just make sure you choose the correct one. And again, I have examples on this. We'll go through it. And click the intersection. If you guys all stay quiet like this and pay attention and help each other with the button pushing, this will go super quick. All right, so here's an example for the age of a car and its value. Real quick before we go and type it in. As the age of the car goes up, what happens to its value? Does that make sense? Unless you have some kind of like antique car that's, you know what I'm saying? Like most cars, the second you drive them off the lot, it's going to start depreciating. Also, is the car worth $24 and then later on worth $8? No, so make sure you're paying attention. It's in thousands. This is $24,000. And then as it depreciates, it's worth $8,000. Okay. I'm going to share my screen so that this will show up on the recording as well. And so we're in Desmos graphing calculator. So go to there and we're going to follow these steps. Watch. Do you see this plus sign right here? Click that and choose table. I need for 100% of you to do this. You literally can't get the answers without typing this. Okay, it's my job to make sure that you all have it. Then you're going to put in the data. I'm not going to toggle back and forth between the screens because I don't want to make you all seasick, but do you see on your paper the age of the car? That's X. What are we going to put in those X columns? Like, what are those numbers? Years. So it starts with 1. It just goes 1, 2, 3, 4, 5, 6, 7, right? Yeah, and you can just hit the down arrow or probably enter would work as well, but just go ahead and enter those. And then Y is your value, so go ahead and enter those. Again, this is mindless button pushing, but just make sure you don't do a typo or it's not going to work. Like, it's easy, but it's also easy to mess it up. So you have to really pay attention, but you actually don't have to do any work for these problems. The calculator is literally going to like spit out the answer at us.
It's not straight.
Correct. It's not perfect, is it? It's the best we can do. It's best fit. Did everyone get the data entered? Do you see the magnifying glass right here? This one? Right here? It says zoom fit. If you hover over it, hit that and it will make the window good. So do you see how this is relatively aligned? Like, it's not perfect, but it's line shaped. Okay. So, oh, it was right down here. Mine went away because I already clicked it. Right there. And what that does is it makes the window nice for you. So it looks line-ish. It's not perfect, but we're going to do the best we can. So click right down here in the second little box, and you're going to do y equals mx plus b, but with those couple of little changes. You have to put a 1 after the x and the y, and instead of an equals, you're going to use the tilde. The tilde is next to the 1 key, but you have to hit shift to get it. Do you see that in the upper left of your keyboard? All right, so it's y1 tilde, thank you, mx1 plus b. So again, it's this right here, y1 tilde mx1 plus b. It's y equals mx plus b but with a tilde and then put 1s after it. Oh, you can't make the 1 go down, you just put a 1. Oh. So like I write it up here with like kind of a subscript. You can't make the 1 be a subscript though, just hit 1. And then the tilde, it's right, the button for it is right next to 1 on your keyboard, but you have to hit shift to get it. All right, so let me share again. Sorry, I went back to the screen so I could like pause it. All right, so do you guys see this information down here, M and B? Do you guys see this right here? Okay, M is negative 2.5, B is 26.7. We'll just round to 1 decimal point, okay? So when we go over to our paper, find the curve of best fit. It's gonna be y equals, and I can't have both screens up here at the same time, so help me out. What was M again? You guys have it in front of you. With negative 2.5, all right, negative 2.5x plus, and then what was B? 27. Yeah, we'll round to 1 decimal point, so 26.7. So like that. Okay. Interpret the slope and y-intercept. Slope needs to have the word per in it. Do you remember something per something else?
Yeah.
Okay, so what's going on with this data? The car is losing value, right? So the car loses. Now, what was our slope? Negative 2.5. And that was it in thousands of dollars? So 2.5 in thousands would be 2,500. The car loses $2,500 per year. Why didn't I make it negative? Because I said losing, like the losing takes care of the fact that it's going down. It's negative. The car loses $2,500 per year. Bummer. All right. What does the y-intercept mean? This right here. What does that mean? If that's where we started, what does that mean? So the car cost how would I put this in thousands? 26.7. In thousands, though, would be, yeah, 26,700. The car costs 26,700 to start with. That was like initially. Your y-intercept is where you start. That's like at times 0. Your slope is like going to have the word per in it, something per something else. Now here's the predictions. Use the equation to predict how much the car will cost when it was 10 years old. You have to decide, is that 10 the X or is that 10 the Y? Now it says years old. So is years X or Y? X. So it's X equals 10. We need to find Y. Y is like the question mark. I'm going to share my screen again. You kind of have to deal with this because I can't have both screens up there at the same time. Come back down here to the third blank and put X equals 10. And stay here with me because I want to have time to at least go through one more whole example. X equals 10. Do you see this line that showed up over here at 10? All you have to do is click that intersection or even just hover over it. Do you see this intersection right here? It's 10 comma what? Whatever that is your answer. 1.714. Do you guys see that? Now, when you write it on your paper, it has to be in thousands though. So it's $1,714. So what that means is after 10 years, this is what the car's worth. We're making that prediction. Okay. I want to at least get through example 2. Table below shows the relationship between study time and test scores. Hey guys, the more you study, what's going to happen? Your grade will go up in theory. Okay. The more you study, the better your grade should be. So what you're going to do is go back to your Desmos. I'm going to X out this X equals 10. I don't need that anymore. So I got rid of that. And go back up here and change the data. And you can kind of just type over what's already there. So in the X's, you're going to put the study times. And then in Y, you're going to put the test scores. And again, this is mindless button pushing. The calculator will literally do the problem for you, but you just have to type everything correctly. So everybody just take a minute and do that. If you leave any of them out, it won't give you the right answer. It's not that bad. Look, I just typed them. And then hit the magnifying glass. Now, if you're watching this video, there's going to be a good bit of blank space here because I want to leave this screen up and I can't pause the recording with this screen up. So if you're watching this video, you're going to have to like fast forward through. There's going to be a little bit of a blank space here because I'm going to wait for everybody. I'm going to stay paused until everybody's screen looks like mine.
I'm sorry, one.
All right, does everyone's screen look like mine?
Oh, wait. Oh.
All right, does everyone's screen look like mine? Good, okay. So scroll down here. What are the slope and the y-intercept? We're gonna round to the first decimal point. Do you see that 0.2? Are you guys with me here? 0.2 and then 71.6? Okay. So we're gonna write that on our paper. Y equals 0.2x plus, oh gosh, what was it? 71 point something? 6. Okay, I can't have both screens up at the same time, so you gotta help me out. So slope, when you interpret the slope, you have to use the word per. It's something per something else. We're talking about study time and test score. So your test score is gonna go up. Remember how the negative slope was something going down? This one's gonna be going up, like going up or going down is what your slope is doing. So the test score goes up, and then what's our slope? 0.2. I guess that's percent because your grade is in percent. Test score goes up 0.2% per what? It's going to go up per minute you study. Per minute of studying. The more you study, the more it's going to go up. But that word per has to be in there. And don't make up like the problem. It's going to be written in there. Study time, test score. Bless you. And then this is our y-intercept, 71.6. What does that mean? That's where you start. So if you don't study at all, like 0 minutes of studying, then you would probably get 71.6. All right, so you get 71.6% with no studying. The y-intercept is where you start, so that's at 0. So like with the car, it was 0 years have gone by, that's how much it costs. If you study 0 minutes, then you can expect about a 71.6. That's what the data is predicting. So here, let's do a couple other predictions. Predicts the test score if you study 40 minutes. You have to check whether that 40 minutes is the X or the Y. So the studying time, is that X or Y? You are going to go down to the next line in your Desmos, put in X equals 40, And wherever it intersects, it's going to give you your answer. And I'm going to share my screen again so we can do this together. So I'm going to come down here, type in x equals 40. It'll put in a line at 40. Do you see that there? And you can either click on or hover over that intersection. If you study 40 minutes, what's your grade predicted to be? 81.6%. Good. D is the other way around. It says predict how long you studied if your test score was 78. So look back up here. Test score is X or Y? Test score is Y. So you want to put in that Y is 78. How long did you study? If you got a 78, you probably didn't study that long. Okay. So I'm going to share my screen again. I can get rid of this x equals 40. And I'm going to type in y equals 78. This time it's a horizontal line. Remember Hooyvaks? And you're going to either click on or hover over that intersection. When your test score was 78, how long did you study for? 25.6 minutes. Good. I'm just going to say one more thing to make sure this shows up in the recording. We'll use this as a jumping off point for when we come back from break. These are just more examples of the same thing. I'm going to fill out number 3 and number 4. If you want to try them and check your answers, we'll do this one as a warm up when we come back from break. I was going to have us measure our heights and our arm span and collect our own data and type that in. So we'll do this as like a jumping off point when we come back. I'm going to fill these 2 in and post the answers. You have 5 homework questions to do, okay? And it is literally just typing in the calculator. But listen, I'm going to give you a choice, and I'm recording this while I say it so that it's on the recording. Delta Math, the questions are good, but they are very, very picky about how you round. Some of them are to the 10th, some of them are to the 100th, some of them are to the 1000th. And if you round incorrectly, it will mark it wrong. So I'm going to give you 2 choices. You can either fight through that until you get 5 of them right, or you can write your answers down on a piece of paper and turn them into me, which I actually kind of suggest. And for me, just round to 1 decimal point, because they are very picky with the rounding. And if it's even off by 1 decimal point, it will mark it wrong. Do you get what I'm saying? We all understand? Okay, so you can either fight through that and just do it on the computer, or you can write down your answers and physically hand them to me, and I will count that as your grade. But you have 5 of them to try over break.